Hello students, welcome to this tutorial of introduction to physiology of blood, one of the excitable topics. Of course, just need to pay attention and as we go through, as we discuss. So with the physiology of blood, there are some specific objectives that we are going to focus on in this tutorial. The first one, we are going to define what blood is. We are also going to explain the functions of blood. Then we just want to appreciate the blood plasma as a component of blood. On the blood plasma, specifically, this is what we're going to venture into and describe it in more detail. However, we also have the other component, which is formed element, and we are not going to focus on that one entirely. So these are going to be our three major objectives in this session. So let's get started. So what is blood? If you may ask yourself a question to say, what is blood? Okay, of course I know there are a lot of definitions that you can give to what blood is. Okay, but these are things that you should know about blood. Okay, so blood is the only fluid tissue in the body. We looked at other tissues, the muscle tissue, connective tissue, nerve tissue, and blood is also featuring to be the only fluid tissue in the body. So this is a specialized type of connective tissue in which formed elements are suspended in non-living fluid matrix called the plasma. So this is basically a description that I can give today about what blood is. So we know that it's the only fluid tissue in the body, and it's some kind of specialized tissue in which formed elements are suspended within a non-living fluid matrix, which is called the plasma. And we have only two major components of blood, and those two major components of blood is the formed elements and the plasma. The plasma is the liquid part of blood where these formed element cells are embedded in. Okay, so now let's look at some physical characteristics of blood. And the physical characteristic of blood that you should know, one is that blood has a viscosity. So the viscosity of blood, or rather the thickness, is around 3.5 to 5.5 cent/pascal. Basically, the viscosity comes as a result of stick opaque fluid due to the presence of red blood cells, because the red blood cells, they are thick and thick, so this brings about the thickness. Okay, so basically the thickness is measured in pascal per second, and these are different sub SI units that you can find, the cent pascals, etc, etc. Then with the color of blood, we have scarlet red. When blood is looking scarlet red, or rather bright red, it means there is high oxygen. So whenever there is high oxygen, the color of blood becomes scarlet red or bright red. However, if this becomes the opposite, in cases where there is poor oxygen perfusion, the color changes to dark red. So when the blood is looking dark red, just know that this particular person is having less oxygen perfusion, or poor rather. So we've done two. Then when we go to the pH of blood is around 7.35 to 7.45. Most of the recommended books are going to tell you on average it's about 7.40. So this pH of blood is described to be slightly alkaline, because 7 is neutral. When you are going the other side, we are going to the basic side. So because it is above 7 it's above 7, then we are going to call it slightly alkaline. Okay, and then when we go to the temperature, the pH of blood is very, very much important, because there are implications. Above the average or below the average, they have their own condition in the body and they have their own implications. So it's very much important that blood is kept at this particular pH. Then we got the temperature. So blood temperature is about 37 degrees Celsius. This is just the same as the body temperature. So you should take note of that. It's around 37 degrees Celsius. And then when we go to the blood volume is just looking at how much of blood do you have in your body. Okay, so blood is a liquid, so everything that is there, but when you calculate the total volume of blood, how much should you have? So in males, there's a difference in volumes between males and females. So in males it's slightly a bit higher, which is 5.6 liters, and then in females it's about 4 to 5 liters. So 5 to 6 liters and then 4 to 5 liters in females. And you should note that blood accounts for approximately 8% of the body weight. Okay, if you are 70 kg, then 80% of 70 kg has been made from blood. Important to know that. And then we should know that the amount of blood varies with body size, changes in fluid concentration, changes in electrolyte concentration, and amount of adipose tissue. You should know these things. They affect the blood volume, your body size, fatty content, age determines all this. Okay. Then we go to density as another physical characteristic of blood. So when I talk about density, I talk about specific gravity. So what does the specific gravity mean? It just refers to the weight of blood compared to water. Okay. So when you look at the specific gravity of water, it's taken as 1, which is 1 milliliters of water weighing 1 gram at exactly 4 degrees Celsius. Now, how about in male and female? In male, it's about 1.052 to 1.063. Then in females, it's about 1.050 to 1.056. Okay, so usually in male, it's slightly higher than female. And then how about osmolarity? First of all, we should know what osmolarity is. Osmolarity, we're just looking at the concentration of solutes in the plasma. The solutes, bicarbonate, calcium, potassium. How if we calculate all those components using the SI units, milliosmoles, is it giving us the 300 milliosmoles? So the 300 milliosmoles, this is the average, this approximate osmolarity of blood. Okay, and then we also look at the salinity. Salinity is just the concentration of sodium chloride in the blood. It's about 0.85%. So it's very much important to know on the osmolarity. Some of the clinical significance is the use of fluids. We have colloidal, osmotic fluids. You use fluids like Ringer's lactate, normal saline. You should know the osmolarity for Ringer's lactate and normal saline, and you should know the implication of using normal saline and in what situation are you going to use Ringer's lactate. Okay, those most are going to be discussed on fluid disturbances. Okay, so now we are done with the physical characteristics of blood. Just to revise, we talked about the pH of blood, which we said it is about 7.35 to 7.45. We talked about the temperature, which is just close to the body temperature, which is 37 degrees Celsius. We talked about the osmolarity, which is about 300 milliosmoles. We talked about the salinity, which is about 0.85%, just sodium concentration in the plasma. Then we talked about viscosity, and we also talked about the color of blood. So make sure that you know the exact figures in whatever that I have mentioned. Then now let's look at the function of blood. On the function of blood, these are simple and straightforward. So blood plays some and transportation function, for example, substance distribution, regulation of blood levels of particular substances. It also plays some regulatory function. It also plays some body protection. So now let's look at exactly how these three functions are carried out in the body. On the distribution, what does blood do? It transports oxygen from the lungs and nutrients from the digestive tract to the tissues. Okay? And then apart from that, it also distributes metabolic waste from cells to the lungs and kidneys for elimination. Okay, and then from there, it also plays a critical role in transportation of hormones from endocrine glands to target organs. Remember, when we're talking about endocrine glands, we're talking about ductless glands, where they don't have ducts. They just use blood so that these hormones can reach their target organs. That was in the distributive, which is transport function of blood. Then we have regulation function of blood. One of them is that it appropriates body temperature by absorbing and distributing heat to other parts of the body. So body temperature regulation, maintaining body pH in body tissues using buffer system. So I'm going to display some equations on how blood maintains body pH in body tissues using the buffer system. And then apart from that, it also maintains adequate fluid volume in the circulatory volume. So now I just said I'm going to display some how does blood helps to regulate pH. So now we described to say on the pH, we said the normal range of pH is that 7.35 and 7.45. That's what we said. So what usually happens is this. Here we mean to say if there is any figure below this, meaning going below 7.34, 7.33, then that we call it acidosis. Okay, remember when we are growing below 7, we are going to the acidic region. So whenever this pH drops below 7.35, then we are going to call it acidosis. And then in a situation where we have this pH exceeding the upper limit, this is the lower limit, this is the upper limit, where this pH is exceeding 7.45, it's going to the it's becoming more alkaline, so we call this to be alkalosis. Okay, alkalosis. So we don't want this to happen in the body because they have their own severe implications that they come to the body. They are going to disturb a lot of things. They are going to disturb blood pressure. They are going to disturb a lot of metabolic activities. Okay, so now we have the buffer system here, where we can utilize two equations. The first equation is that since we have water, we have water and the carbon dioxide, right? We have water and carbon dioxide within blood. This formed what we call carbonic acid. Okay, and then carbonic acid can dissociate. This is a reversible reaction, can dissociate to form what we call the bicarbonate plus the hydrogen ion. Okay, I want you to focus on these two equations. So now in the body we have this happens in blood. This process is facilitated by an enzyme which we call carbonic anhydrase. So what happens is this: when water reacts with the carbon dioxide, this is going to form carbonic acid. Okay, and we can reversibly dissociate this carbonic acid. It can be dissociated to form what we call bicarbonate and what? Hydrogen ion. So now what happens is this: in a case where the temperature is going 3.75, this is, we are saying it is going below 3.75, we mean to say it's going to more acidity. Okay, it's going to more acidity, it's going to acidity region. So you know that hydrogen ion is what brings about the acidity. It's what determines the acid. So if at all this particular person, if at all their pH is going below 7.35, we mean to say they are having more of the hydrogen ions in the body. Okay? If they are having more of the hydrogen ions in the body, then what should we do? Okay? Carbonic acid is toxic. Okay? Carbonic acid is toxic, but in this form is more dangerous. So in this case, what happens is, if it's going to more acidic, this free hydrogen ion in the blood is going to combine with bicarbonate so that we form carbonic acid. This carbonic acid is going to be eliminated through the lungs. Carbon dioxide is going to be removed. Remember, carbonic acid is basically water and carbon dioxide here. So if this reaction occurs in blood, hydrogen combined with bicarbonate to form carbonic acid, then carbonic acid is going to dissociate and remove this acidity through the respiratory system. Or apart from that, what other things happen is that the kidney also plays a critical role. Okay, the kidney plays a critical role by excreting more of the hydrogen ions if the temperature is if the pH is becoming acidic. You understand? So what we don't want is to have a lot accumulation of hydrogen ions in blood, because this will mean blood will continue the pH will continue being reduced and reduced. So we want to combine this hydrogen ion, since it is a reversible reaction. So we are going to combine hydrogen ion with bicarbonate to form carbonic acid, so that this carbon dioxide, this we know carbonic acid is water and carbon dioxide, this carbon dioxide can live through respiratory system. We have controlled hydrogen. And now let me bring you a different scenario. Let's forget about this scenario. In case you didn't understand, please pay particular attention on this scenario. Now that we are having 7.45, the temperature is going above this, meaning it's going to alkalosis. Okay? Here the problem is that there is less acid in blood. Okay? There is less acid in blood. So you can actually tell me what now we should do. If we have less acid in blood, it means we don't have enough hydrogen ions in blood. So we need to, this process now is going to dissociate by carbonic, that's when carbonic acid dissociates to bicarbonate and the hydrogen ion. So this hydrogen ion is going to reduce this pH. If the pH was somewhere around 7.55, it's going to reduce it and return it back to 7.45, because hydrogen ions have come. Hydrogen ions is an acid. So acid has come and brought this back to its usual state. And this is how this basically equations works here. Okay, if the blood is more acidic, then we don't need hydrogen ions. So what do? Hydrogen ion combine with bicarbonate to form carbonic acid so that it can be excreted, or hydrogen ions can be excreted directly by the kidney. Okay, and then if we are lacking hydrogen ion in the body, then we need to dissociate this. We need to break this down so that we can have a lot of hydrogen ions in cases of alkalosis, meaning we have low acidity, so that we can have it again. You get that? This is a simple buffer system. These are simple buffer system equation that happens. So now let's continue with the third function of blood. The third function of blood is that it plays some kind of hemostasis. So hemostasis is basically involved in clotting mechanism. When you cut yourself and blood is coming out, continuous coming out of blood can cause some conditions like shock and other things. So we don't want that. So we initiate the clot formation when a vessel is broken, so that it can be fixed. So it has offered protection. Then apart from that, it's also important, blood is also important for activating the complement proteins and activating white blood cells to defend the body against foreign invaders. So these are two things that we're going to look at today. It's about hemostasis and also fighting infection. So hemostasis and fighting infection. These are the two major protection offered by blood to the body, of course. So now we are done with the physical characteristics of blood. We are done. We described blood. We went to physical characteristics of blood. Then we went to functions of blood. Now we want to have a glimpse of what components of blood. We want to look at the composition of blood. Remember, I already mentioned this in the beginning to say we have two major components of blood. We have the liquid part, which is called the plasma, and then we have the part which is full of cells, white blood cells, red blood cells, and platelets, and that is what we call formed element. The catch is this: the white blood cells, red blood cells, and platelets are embedded in the non-living matrix, and that we are calling the plasma. So the formed elements are embedded within the plasma. So the plasma is a bit high, 55%, and the formed element is around 45%. So now we need to look at what really comprises of the plasma, because questions are going to tell you state the components of blood plasma, 10 marks. State the components of the formed elements, 10 marks. So we want really to know what are the components, what are the elements rather, or the features rather, of the blood plasma. And whenever we're talking about plasma, we're talking about the liquid. So what is within this liquid that you should know? So now let's go looking at the plasma. That's where we're going to focus more. And on the formed elements, we're going to talk about it in the next tutorial. So with the composition of blood, we know that we have formed elements. The formed elements have erythrocytes, which are red blood cells, leukocytes, white blood cells, platelets. They are fragments of megakaryotes in the bone marrow. So basically these are thrombocytes. So the components of the whole blood is made possible in the health setup using what we call centrifugation. The centrifugation is a process where you use a centrifuge so that you can separate the plasma alone and the formed element alone. And this is how it looks. When you get the blood of a person and then you withdraw it, you put in the test tube and then you put in the centrifuge, then this runs and then runs and runs, and then it separates. The plasma becomes on top and the formed element settles down. This is due to some kind of density. So erythrocytes are more denser than the plasma, so they are going to settle down, and because the plasma is less dense, it's going to be on top. Okay, and then here we just have the buffy coat, both the component of the erythrocytes and the plasma. So now with this, when you look at the capillary tube here, we are going to focus on the yellow part, the plasma, which is 55%. So what is really the plasma? Okay, plasma constituents. Questions are going to be asked. The state components of the blood plasma. So whenever you are given 10 marks, we want to make sure that you mention all 10 components of the blood plasma. If you mention 8, you are going to be given 8 marks. So if you are to state the components of the blood plasma, 20 marks, you need to also state means explain, not only listing. You say water, then you end up losing marks. So here we want to know the color. So you're going, we have the plasma constituents. Blood plasma, what is the color? It is a straw colored stick fluid. And these now are components. Water, 90 to 92%. Then we have proteins, 6 to 8%. In the protein, we have albumin, globulin, creatine proteins. Okay? And then we have solutes. Solutes are 2%. Okay? So basically, these are major components of the blood plasma. Water is about 90 to 92, proteins are 6 to 8%, and solutes are 2 to 2%. So when you're talking about proteins, make sure that you also mention on the albumin, globulin, and creatine proteins, because they have own notes ahead as we go ahead. So, and then apart from that, we also have some organic nutrients, which is just a lower percentage. Organic nutrients like glucose, carbohydrates, and amino acids. And then we also have electrolytes like sodium, potassium, calcium, chloride, and bicarbonate. Then we also have the non-protein nitrogenous substance like lactic acid, urea, creatinine. And then we also have some respiratory gases like oxygen and carbon dioxide. These are the components of the plasma. 1, 2, 3, 4, 5, and 6. So all you need is just to spice them up, write few statements on them so that you can get the full marks. So now on the proteins, remember I said proteins are made up of 6 to 8% according to the statistics that were just from saying. And then we said water is made up of 90 to 92%. Yes, and then solutes are made up of 2%, and then we have other substances there, okay, which are there, non-nitrogenous substances like urea, okay, and then we have some respiratory gases like carbon dioxide and the oxygen. So we just want now to spice things up, and always remember to include these percentages. They are very, very much important. So in the blood, in the plasma proteins are made up of about 6 to 8% of proteins. Within these 6 to 8% of proteins, we have albumin. Remember those three I mentioned? Albumin. Albumin accounts to about 55% of total proteins in the blood plasma. Most abundant blood plasma. Questions are going to come. Albumin is the most abundant in the plasma proteins. It's the most abundant. Okay? So it's usually a carrier to shuttle molecules through circulation. So about the albumin, it has several functions. Some functions are not even desirable to the body. It does a lot of stuff. Okay? It's also an important blood buffer, and then it also maintains osmotic pressure of the blood. Okay? When we're looking at the pressures in the blood, we're going to look at hydrostatic pressure and osmotic pressure. So usually the osmotic pressure we're talking about is the hydrostatic pressure and the plasma oncotic pressure. The hydrostatic pressure is the pushing pressure, and the oncotic pressure is the sucking pressure. This is what it means here. So globulin accounts to about 36%. You see why albumin is the most abundant. Okay? And globulin has some chains, A and beta globulins, role in transport. Okay, then Y globulins are immunoglobulins, let's say IgG and IgA. Then we also have crotin proteins account for 4%, fibrinogen and prothrombin. So we have talked about all the three components here: albumin, globulin, and crotin proteins. You are done with the proteins. So you should know that how did these scientists try by all means to know that we have alpha, B globulins that are involved in transport, Y globulins. This is just done and made easier through the process what we call electrophoresis. In electrophoresis, what happens is that this is a device that works with under electrical. So what happens is that it separates some component into their subunits, like smaller ones. For example, separating proteins into alpha and beta globulins. All that it was just done by this machine called electrophoresis. Electrophoresis is the process of determining using a machine that runs by electricity. So now remember I said we're just going to describe a bit about formed elements. That was the plasma that I gave you. Okay, you should be able to note down. Then on the formed elements, this comprises of the 40% of blood. Let's not confuse ourselves. What is formed element? Formed element is confusing me so much. No. Formed element, we're just talking about cells that are embedded within the plasma that we're just from describing. So what are formed elements? Basically, we're talking about red blood cells, white blood cells, and platelets. So erythrocytes, leukocytes, and platelets makes up the formed element, as simple as that. So we should know that only the white blood cells are complete cells. Let me explain on this one. For something to be called a complete cell, it needs to have a nucleus, because nucleus controls cell activity. So if a certain cell is having a nucleus, it means it's controlling its own cell activity. So it's considered to be complete nucleus, complete cell. So white blood cells are complete cells. However, when you look at red blood cells, they don't even have a nucleus. Okay? So red blood cells have no nuclei or organelles, and platelets are just cells, fragments of megakaryotes. They are not even one single matrix. They are of different components. So know this important thing. Only white blood cells are complete cells. So most deformed elements survive in the bloodstream for only a few days. You understand? Because they are lacking some important features like nucleus. Okay? Most blood cells do not divide but are renewed by cells in the bone marrow, because they are lacking some important features of the cell. They can't do things by themselves. So most of the formed elements, they die. Okay? And their survival depends on the blood stream for only a few days. Right? So this is the summary of the components of blood, and we are going to end here. We have the plasma, two major, and the formed element. The plasma, we have proteins, we have nutrients, we have amino acid, we have gases, we have electrolytes, we have nitrogenous and non-nitrogenous waste. Overall, don't forget water. Okay, don't forget water, don't forget solutes on the plasma. Just pass through my notes. And then on the formed elements, we just talked about platelets, erythrocytes, and leukocytes. And then now, these same leukocytes, which are white blood cells, they are further divided into granulocytes and agranulocytes, which we are going to look at in the next video tutorial. For today, I say goodbye. And if you've been enjoying the content, please make sure that you subscribe so that you don't miss new content that might be uploaded. And if you're not registered with Step Up Academy, please make sure that you register with the Step Up Academy, the only trusted platform for nurses at the University of Zambia and other universities like CBU, Apex, Mungushi, and other nursing schools, colleges like St. Luke's, Lusaka College of Nursing. We have Apex, we have Eden, a lot of students with Step Up Academy, and they have never regretted their decision till today. All right, bye bye.